Hello and welcome to my audience, both of you. I am John Bergman, the founder and CEO of Guild Software, and I'm going to be talking a little bit about how we've been evolving our game recently, and both in terms of what we're currently in the process of doing and optimizations that we're going to be making in the immediate future that will be taking advantage of ARM technology and also allowing us to do some next generation rendering. So, just to jump in real quick, we're a cross-platform MMO. We've been around since 2002 on the PC, Windows, Mac, and Linux back then. We brought the game over to Android in 2010, launched it in 2011 with relatively good support and good experience there. Constantly kind of evolving process on that platform to bring everything together and make it work on tablet devices and phone devices using the exact same code that we use on the PC. So it's a completely native port on every platform that we support. So we're a constantly evolving title with patches dropped roughly every week, which has all sorts of interesting ramifications for trying to develop a game like this. And the content has to scale all the way from a gaming desktop all the way down to a mobile phone and vice versa. So it's a single universe experience with completely dynamic content changes, which will kind of feed into what I'm going to be talking about for the rest of this session. So moving ahead, what we're looking to do is drastically expand our content to increase the object count by probably about a factor of 100. And just to give you an idea of what I'm talking about, I'm going to flip over real quick and show you a brief trailer that'll give you some idea of what sort of rendering we're doing already, which will also kind of inform where we're headed from here. Assuming that this plays. There we go. So this is the current trailer for the mobile version, and at this time these assets are most closely going to be reflecting the mobile version for the immediate future and the recent past here, but most of the stuff that we're working on is going to be the next generation version of this. So as you can see, we've got like large space battles with large numbers of people potentially on either side, fairly significant asteroid counts, upwards of 5,000 to 8,000 objects in any given sector. And, upwards of 7,000 individual sectors of space. So our sectors themselves are actually procedurally generated, and that's kind of a lot of what I'm going to be diving into here in terms of how we can continue with our procedural content generation while getting larger and larger and more complex asteroid fields that do more and more interesting things, creating more dynamic visuals for the players, as well as making situations where we can actually adjust the sector to player impact in one way or another. So basically, as a designer, I always want our content to be as impacted by player activity as possible. That's a core goal for us, and that's part of why we've made some of the choices that we have. So anyway, I'm just going to jump out of this real quick and get back to the main talk. So anyway, we have completely dynamic sector data that's updated on the fly. And what that means is, unlike most MMOs, which retain all of their sector data in the client, basically the entire game universe exists in the client at any given time, for us, we're actually transmitting all of the data over the network at load time for the individual user, which sounds a little bit crazy, but we're able to pull this off pretty effectively. And the benefit of this is that we can constantly manipulate our universe at any given time. We can, have player impacts, have large, visible changes that are a result of that. And we haven't done as much with this feature as we wanted to when we originally rolled out the game, but that's still an important part of our goals moving forward. We're also completely unlimited in the fact that we have a procedural universe. So as we continue to expand the game universe, we want to be able to create as many sectors with new and interesting content as we want to. Now, very long view distances are also obviously a big deal because you run into a Z-clip problem if you just don't handle anything at all. And we want to see unlimited asteroid fields. Basically, you fly into a sector that might have millions or even tens of millions of asteroids going off as far as the eye can see with all sorts of detail and everything going on. And that's part of what we're looking to achieve here. So in terms of how we're approaching this, We're basically building something right now that I'm terming smart assets. And the concept of a smart asset is basically, instead of sending a huge list of individual objects to spawn across the network, we're sending an object with a bunch of Lua code attached to it and also some algorithms that are kind of baked into the entire asset, which tells the asset how to procedurally arrange itself on the client. And then the client actually generates the content. So because of this, it gives us the flexibility that we're not actually transmitting much data across the network, but we're able to have huge amounts of flexibility in the sort of content that will be visible on the client. And we also don't have the downside of the client having to store an unlimited amount of sector data, which would become basically untenable for something with an unlimited universe. So we can use background threading, thanks to lots and lots of ARM cores, to do this sort of thing in the background. So if a player is in one sector and they want to traverse to another sector, we can look at what their navigation route is going to be and begin generating the sector data in the background, and then we can cache that data until such a time as it changes and so on. Beyond this is really the core issue of how one handles rendering with these kinds of asteroid fields, and that is, how do you deal with the z-clipping ranges? How do you deal with just the number of draw primitive calls and things like that? And basically, this is an area where we're still digging into this. So this is kind of like the next gen of what we're going to be digging into over the coming month. ARM asked me to come out here and give kind of like a current gen talk of what we're right in the middle of right now. So multiple layers of depth are used to sort objects into kind of different distances. And then we're grouping the objects together dynamically to reduce the number of primitive calls. The furthest objects we can cook into imposter layers. So basically, like objects that are really far off into the distance can get cooked into the background, and then those backgrounds can be updated as the error increases, such that the player moves a little bit, and now the positions of those asteroids will have shifted with respect to their current perspective. So then we'll just re-render those things in the background, keep it fairly transparent. Similarly, we're able to use things like OpenGL ES 3.0 to do instancing as part of an optimization for rendering, and we're also able to use the multiple Z layers to allow us an efficient way to maintain basically Z buffer accuracy across an extremely large distance while not losing any precision in any of the interim steps. So so far so good on that. We have yet to see how all of that will completely cook out. We're looking at a number of different options for how exactly we're going to be optimizing some of these aspects. And if we get to a Q&A portion and if people have any questions, please keep in mind that I am not the engine architect on this. I'm more of the creative director for the game. But I'm very aware of this stuff mostly because I'm pushing the design, and the design is what's required in order to have this kind of technology. From a design standpoint, I want to see players doing things with their own locations within asteroid fields, doing things with their own stations that they're able to roll out, and being able to actually manipulate the territory where they're existing. So all of this will hopefully continue to support that. So that was kind of the general overview, which went a little bit faster than I originally anticipated. But we're going to be continuing to evolve this over the coming year. And all of these changes that we're looking to integrate will also get integrated into our engine, which we may eventually make available. So if anybody's interested in our engine technology as a whole, you can take a look at that on the Naos Engine website and learn more about that. Or you're welcome to take a look at our game site or shoot me an email for that matter. And at this point, I guess we can go ahead and dig into any questions that anybody might have.